let us look at this new graph, which is g of x equals 2 times sine 4x plus 3. So first let us describe the transformations in here. So transformation number 1 is a vertical stretch by a scale factor of 2. Transformation number 2 is a horizontal shrink by a scale factor of 1/4. And the last transformation is a translation up by 3 units. So let us go ahead and write the equation here. So f of x, actually, I'm going to take this out and say f of x is going to be a times sine b of x plus k. So k is our vertical translation, b is our horizontal stretch or shrink, in this case it's a shrink, and a is our vertical stretch or shrink, and in this case it's a stretch. So when we are making the table of values, as before, we are going to create the table of values with the horizontal stretch or shrink, in this case is shrink, included already. So let us go ahead and first figure out our period. So our period, because b is going to be 4, is going to be 2 pi divided by 4, which will give us pi divided by 2. So this is going to give us our horizontal shrink. And again, I'm going to make that unit circle. And so my points here are 1, 0, 0, 1, and this is negative 1, 0, and this is 0, negative 1. So these are our points for 0 and pi over 2, or 90 degrees, and then pi, and then 3 pi over 2. So we'll have the graph that we are concerned with. We are concerned with the 4 parts of the graph. Where does the 0 occur, the maximum occur, the 0, the minimum, and the other 0 occur. Since we are shrinking this graph, we are going to make our table of values first. So I'm going to say 0 right in the middle. And here is my pi over 2. So remember, this is the period, the pi over 2, and I place that in the last place, as well as I can place the opposite negative pi over 2 on the left place, the first place. So now I need to find pi over 2 times 1/2. That's going to give us the center of the graph. So pi over 2 times 1/2 is going to occur at pi over 4. Then to figure out the first place is going to be pi over 2 multiplied by 1/4, because this is a quarter point. So this is going to give us our pi over 8. And then here for this box, we are going to have 3/4 times pi over 2. So that's going to give us 3 pi over 8. All these x values are already the x values for the shrunk graph. So that means our maximum is going to occur at pi over 8. And our next 0 is going to occur at pi over 4. And then this is our 3 pi over 8. And this last value will be our pi over 2, right? So now let's write the negative one. So it's negative pi over 8, negative pi over 4, and negative 3 pi over 8. So we are going to have to figure out our y coordinates. So these will be for the parent function, which already is having its horizontal shrink on it. So this is going to be 0, 1, 0, negative 1, 0. And here, if I'm going backwards, I'm going to get negative 1, 0, 1, 0. So let's go ahead and graph this. So we are going to say we start on pi over 8, and then we go pi over 4, then 3 pi over 8, and then we have pi over 2. I chose 2 squares again to be the first increment of the graph because it just makes it easier to graph that way. So negative pi over 8, negative pi over 4, negative 3 pi over 8, and negative pi over 2. So I'm just going to simply graph first the graph of sine 4x. So this is going to be starting at 0, go to, let's say this is 1, and this is negative 1. So go to 1, and back to 0, negative 1, and back to 0. And this way we go to negative 1, 0, and 1. And I need to move that negative pi over 2 just 1 square over. So this is going to be negative pi over 2. So here is our 0 again. So let's go ahead and create our sine curve, which, as I said, it includes our horizontal shrink. So this here is going to be y equals sine 4x. So the next thing I'm going to do is I'm going to multiply by 2. So I'm going to do a different color, and that's going to give us our 2 sine 4x. So that means I'm stretching everything vertically. So this point is still here. Vertical stretch, 0, down here, and here. And the vertical stretch. And I'm just graphing every part of this graph so you can see the whole process going through every one of the transformations. So this blue graph here is going to give us y equals 2 times sine 4x. So next we are going to graph our midline. So the midline is going to be the line that this graph is going to oscillate around, and the midline is going to be the value of y equals k. So our midline is y equals 3 because we need to move the graph 3 units upwards. So here is 2 and here is 3. So let me see if I can actually make this line nicely. So I can make a line at 3. So this is going to be our y equals 3 midline, which is our vertical shift. And so last now I'm going to graph it in green. So here was our intersection point first, and since our amplitude was 2, we are going up 2, so this here is 4 and this is 5, and then back down to here, and then in the opposite direction. So I was moving every point on this graph 3 units upwards. So if I move here 1, 2, 3, 1, 2, 3, and then again 3 units, 3 units, and 3 units up. So let's graph this with a nice curve. And let us label this equation as g of x equals 2 times sine 4x plus 3. So this is our final graph. And when we describe all our information about the graph, we are going to describe it on this final graph. So let's go ahead and call this midline intersections, because in this case I'm not interested that much in where the graph is intersecting the x-axis, since I moved the graph 3 units up and it's not even going to have an x-intercept, but I'm interested in our midline intersection. So if I describe the first point, it's going to be at negative pi over 2, and the y-coordinate is 3. So this point right here is negative pi over 2, 3, right? So the y-coordinate of all the midline intersections are going to be 3. So the next midline intersection is negative pi over 4, 3. Then the following one is going to be 0, 3. Then the next one is going to be pi over 4, 3. And then the last one here is going to be pi over 2, 3. So now let's talk about our minimums and maximums. So let's go ahead and first find our minimums. So our minimums occur, the first minimum we see is right here. So the order pair for that one is negative pi over 8. And the y-coordinate is 1. And the next minimum is going to occur at 3 pi over 8, and the y-coordinate is 1. And then the maximums, our first maximum occurs right here, and the y-coordinate of that point is going to be 5. So it's negative 3 pi over 8 and 5. Our next maximum is going to be at pi over 8 and 5. So you have to be careful with the information you are giving when there is a vertical translation, because you have to watch out what your y-coordinates of the points will be for the graph. So here is a vertical translation as well as a vertical stretch and a horizontal shrink on a sine graph. On this example, we are going to graph a horizontal translation of the graph of cosine x, as well as a vertical stretch and a horizontal stretch by a scale factor of 2. So let's go ahead and write down again what our transformations are. So first transformation is a vertical stretch by a scale factor of 5. The second transformation is a horizontal stretch by a scale factor of 2. And the last transformation is translation right by 3 pi. So let's write the equation of f of x equals a times cosine bx minus h. Above here, obviously there is no k, so we are not moving up or down. And so we can see that a is our absolute value, a is our amplitude, which is 5, b is 1/2, and the horizontal translation is going to be 3 pi. So now let's go ahead and figure out our period first. So the period is going to be 2 pi divided by b, which is 2 pi divided by 1/2. So if I divide 2 pi by 1/2, I will get 4 pi for the period. And again, I'm going to make my little unit circle as well as the graph of the cosine graph, so you can see. So this is 0, so you can see what points we are actually looking for. So the first point, and then here we have pi over 2, and that's 0, 1. Then here we have pi, and that's negative 1, 0. And here we have 3 pi over 2, and that would give us 0, negative 1. On a cosine graph, we start with the maximum point, and then we go to the 0, the minimum point 0, and back to the maximum point. So here is our 0 radian. This would be our pi over 2. This would be our pi over, this is just pi. And then our 3 pi over 2. And then this would be our 2 pi point. However, we are going to have a horizontal stretch, so let's go ahead and fill out our table in here. So we'll put the 0 in the middle, and then we'll put the 4 pi as the end of the period. So this is our period. So now we are going to find, first I'm finding the half point, so half times 4 pi, which will give me 2 pi. Then here I have a quarter times 4 pi, which would give me pi. And here I have a 3/4 times 4 pi on this box, so I would have 3 pi over here. Let's go to the negative direction, negative pi, negative 2 pi, negative 3 pi, and negative 4 pi. And we are now going to write down our y coordinates with the horizontal stretch included. So we start on the maximum, right? So we started here on the maximum point. Then we go to 0. Then we go to the minimum point, back to 0, and back to the maximum point. And if I'm going to the left, I'm going 0, negative 1, 0, 1. So I'm just following the pattern that I followed to the right. Now I'm following it backwards to the left. So this is going to be just our parent graph, including the horizontal stretch. So let's go ahead and create our graph. So I'm going to have, on this particular graph, because I will have to translate it by 3 pi to the right, I'm actually going to choose each square to represent just 1/4 of the cycle. So I'm going to say this is 0, this will be pi, this will be 2 pi, and then this will be 3 pi. And then here again, negative pi, negative 2 pi, negative 3 pi, and negative 4 pi. So now let us label 1 square to be 1 unit and 1 square to be negative 1 unit. And we are going to graph our graph starting with a maximum point, just like how you see it here. This is our plain basic cosine graph. So we start with a 1, then 0, negative 1, 0, and going in the opposite direction similarly. So I'm going to connect these with a nice curve. And I'm going to label this graph to be y equals cosine 1/2 of x. So now what we need to do is we need to do a vertical stretch on this graph. So I'm going to stretch the graph vertically. So I'm going to use a blue color for that. So 2, 3, 4, 5. So here's 5, 2, 3, 4, negative 5. So when I stretch the graph vertically, every one of the points, y coordinates get multiplied by 5. So let's go ahead and do that. And then we are going to go ahead and graph it. So here it is. And I just noticed that I didn't graph the last point in purple, so this would be the last point, which is our 4 pi, where we turn it on. Okay, so let's label the blue graph. This blue graph is our y equals 5 cosine 1/2 of x. And now I'm going to have to move every point of this graph 3 pi units to the right. So let's get started. Since each one of my squares represent 1 pi, I need to move the graph 3 squares to the right. So I'm moving 1, 2, 3 squares to the right. So my first point is going to be here. Then I'm moving the next point, which is down here, 1, 2, 3 squares. So that point is going to land on 4 pi. And then I'm going to the minimum point, so I'm going to move it 3 squares to the right, so it's here. And then I move to the 0 again, so that's going to move over here. So now I go the left direction, so I start out with this point here, 1, 2, 3 squares, so it's going to land over here. And then I move my minimum point 3 squares. Then I move my other 0 3 squares, and then I move my maximum point 3 squares. So I can graph this graph, which is our final transformed graph. So our green looking graph is actually our final graph. So our graph on the green is going to be g of x equals 5 times cosine 1/2 x minus 3 pi. And I could also see if I wanted to use a different color, let's see if I can use a yellow, that when I'm moving 3 squares to the right, I'm really looking like I'm moving that y-axis to here, 3 squares to the right. So that would be the new y-axis. So again, on this problem, we are going to list the x-intercepts, the maximums, and the minimums. So let's go ahead and get started. So the x-intercepts are going to be 0, 0 is my first one. My second one is 2 pi, 0. My next one is 4 pi, 0. And then my last x-intercept is 6 pi, 0. Then my minimums are going to be pi negative 5 is our first minimum, and our second minimum is 5 pi negative 5. And then our maximums are going to be negative pi 5 is our first one. Our next one is going to be 3 pi 5. And our last one is going to be 7 pi 5. So that point would be right over here.